All right, welcome. My name is John Vesely. I'm here to describe to you the basics behind how a reciprocating single-cylinder steam engine operates. To give you a little background of myself, I partnered with a friend of mine to start Vintage Parts Revival. I've had a passion for old mechanical things my entire life. I am relatively new to the steam hobby. I understand the mechanical principles, but on occasion you'll probably hear me misspeak and use maybe a slightly off or incorrect terminology. But ultimately the key is to get some of the messages out there, help understand what's going on, and I can learn along the process just like everybody else. So anyway, a reciprocating steam engine. This is a little cutaway model attempting to show us what's going on here. When you think about things logically, if I have a steam boiler that's pressurized, it wants to expel steam, and it wants to expel steam constantly in the same direction under the same amount of pressure that the boiler is at. Well, how do we get that steam to be useful for mechanical work? Well, back in the day, we decided that we were going to operate a piston, causing a piston to slide back and forth. It's not quite as simple as directing steam straight to that piston, however. You need to have a series of valves, or a valve that you call a D valve or a slide valve, that controls which side of the piston the steam is being ported onto. That way, you can get the flywheel to roll in one direction or roll the other direction based on what you need for driving the steam engine. Most steam engines don't have any gearing, or any transmission gearing, I should say. So essentially, to make the steam engine go forward or backward, you are simply changing the way the steam is being routed to the piston. That's done with this little valve up top here. It's the slide valve or the D valve, and it's connected to the controls for what's going on with some type of linkages. There's a variety of different designs that were used on different engines over the years. Ultimately, each has their own advantages and disadvantages, but essentially you have to get this valve to slide and move in time with the stroke of the cylinder. So it is a little bit of a complicated linkage, but ultimately that's what you're seeking to accomplish. If you look at this model, I have the lever positioned to the neutral position. You can see that if I force the piston to slide back and forth, I don't get any motion on this top valve, this slide valve, or this D valve. Now, what that means is if I'm pushing steam into this port, without that valve from moving, I'm not porting steam to either side of the piston. So essentially, regardless of the position of my throttle, the engine won't move. If I move this lever to the forward position, you see I change the position on this cam here, and as steam is applied, we get motion of this valve up top, and that way the engine will move in a direction. If we change the direction of this camming, we've crossed over the center pivot point of the cam. The engine now moves in the reverse direction for the respective same amount of steam pressure going into this chamber. If you look specifically close here, it is a rather simple design, and it's just a matter of timing the porting of the steam to the correct side of the piston to get the motion you desire in accordance with the stroke of the piston. It's, for lack of a better description, valve timing on an engine far before the internal combustion engine.